Good evening, everyone. I am Sir Gypsy B. Corpus from San Jose National High School, and welcome to Tele-Turuan Season 10, Module 4 in Grade 9 Science. In Grade 8, you learned about the relationship among the three basic electrical quantities: electric current, voltage, and resistance. You were tasked to construct simple electric circuits that led to your understanding of Ohm's law, and you were able to apply it to everyday situations. Your teacher also led the class in discussing safety precautions in order to avoid electrical hazards such as short circuits through proper electrical connections and proper grounding. Electricity powers all our gadgets and appliances at home. Have you ever wondered how electricity reaches us from the electric power plant? What processes does electricity have to go through in order to reach us at home? Various sources of energy are utilized to provide electricity to power our households. For example, the tremendous energy produced by falling water is used by water turbines to rotate large generators at a hydroelectric power plant. As the water falls from the reservoir, its kinetic energy increases and it flows very fast. The falling stream of water turns a fan-like device called a turbine, which is connected to the generator shaft. The rotation of the shaft turns powerful electromagnets that are surrounded by the coil of copper wires. The coil is connected to a step-up transformer that sends high voltage current to power lines. Other sources of energy at power plants include steam from burning fossil fuels, nuclear reactions, wind and ocean tides. Each source provides the energy of motion to turbines, then to the generators producing electrical energy. Power plants in general use generators to convert kinetic energy into electrical energy. One specific source, however, uses solar panels made of photovoltaic cells to convert sunlight into electrical energy instead of turbines. From the power plants, electricity is then made to travel along cables and wires called transmission lines. Transmission lines are commonly put up between transmission substations, which are regulated by the National Power Corporation. Transmission lines may either be constructed overhead on towers or they may be underground. They are operated at high voltages, send out large amounts of electrical power and extend over considerable distances. From the generating station, the transmission substations step up the voltage to a range of 138,000 to 765,000 volts. Within the operating area, transmission substations produce or step down the transmitted voltage to 34,500 to 138,000 volts. This power is then carried through lines to the distribution systems located in the local service area. The distribution system connects the transmission system to the customer's household. The distribution substations further step down the voltage to 2,400 to 19,920 volts. A step-down transformer further reduces the voltage to 220 volts, the standard AC voltage in the Philippines. This voltage powers most of the electrical appliances we have at home. When we come back, we will try to answer some important questions about electrical transmission and generation. Let us pause for some reminders from our sponsors.